Hi, this is Mrs. Ziegler, and I am going to go over your states of matter notes. So these fill-in notes, which again is accessible in Canvas for you. I'm just reviewing this so that you have a lecture video for this. All right, so again, the different states of matter. So there are actually 5, but you are responsible to know information about the main 3 that you actually learned in elementary and middle school: solid, liquid, gas. So remember, for a solid have particles, the atoms that are in it, that are closely packed together. They are orderly, like in this picture, as you can see. All of matter is always moving, so for the speed of which solids are moving, they are very slow and is basically vibrating in place. Solids are not compressible. When I mean compressible is when you take a solid and you press it, none of the particles can move because they are closely packed together, so therefore there's no space for it to move, so that's why it is not compressible. Solids also have a definite or defined volume and shape, meaning it takes up a certain amount of a certain amount of space, and its shape never changes. For a liquid, so this is an example of what a liquid would look like as its particles. They have space that is in between the atoms that are attracted to each other, so therefore they slide past each other. They have a little bit more space, as you can see, compared to a solid, and in terms of their speed, it moves at a medium speed, a little bit faster than a solid. Okay, it is also not compressible because it does not have space, or does not have a lot of space between the particles. So therefore, when you take a water bottle and you fill up the water bottle all the way to the top, when you press that water bottle, you can see that you can't really press it because, again, there's not a lot of space between the particles. It is also not compressible. Liquids have a definite volume, meaning it takes up a certain amount of space, but does not have definite shape, meaning it takes the shape of whatever container it's in. When looking at a gas, so again, here are particles of a gas. You can see that there's a lot of space between those particles. They are spread very far apart. They are also moving at a much faster speed as compared to a solid and a gas. Okay, they are compressible because, again, if you look, there's a lot of space between gas particles. So therefore, when you press on a gas, there's a lot of space, so therefore they can move. Gases have no definite volume because it does not have a specific amount of space that it takes up, and it does not have a specific shape. So these are characteristics that you need to know about your 3 different states of matter. Now, on top of that, you also need to know the 6 phase changes of matter. Now, in elementary and middle school, you actually know what melting and vaporization, boiling, and evaporation is. Okay, you also know what freezing and condensation is. So these arrows show you what those phase changes is. Melting is when you go from a solid to a liquid. Evaporation, which is the same thing as vaporization and boiling, goes from a liquid to a gas. When you do the opposite, going from a liquid to a solid, that is freezing. When you go from a gas to a liquid, that is condensation. Then the 2 phases that you should have learned in middle school that are kind of new to you would be sublimation, which would be a solid all the way to a gas. And then the reverse of that, which is a gas all the way to a solid, is deposition. Now, we know that water can do the 4. When you go from ice, it's melting. Ice going from ice to liquid water is melting, and then when it evaporates or becomes steam when it's boiling, it becomes a liquid to a gas. Whereas when we have condensation, it's when the water in the air gets cold and therefore then collects and becomes liquid water onto a surface. Where if it continues to be cold, then it can go from a liquid to a solid. Dry ice, which is actually carbon dioxide, is when it is dry ice is a solid and it goes to that fog, which is a gas. That's what sublimation is. To make dry ice, we take carbon dioxide and we slow it down where it goes from a gas to a solid. So on top of needing to know the 6 different phase changes, you need to know how this occurs. Okay, so first thing is, what happens in your phase changes. So first thing is knowing the difference between endothermic and exothermic. So here it talks about what that is. So endothermic, endo means energy going in. Okay, so endo means in, thermic means heat, right? Whereas exo means out. Exo means out, and again, thermic means heat, so out, heat going out. So what happens is when I am putting energy in, that means I'm speeding up these particles to make them move faster. So as they're moving faster, there comes to a point in which that heat or energy stops going into making the particles go faster, but now goes into breaking apart the bonds between the atoms that keep them close together, the attraction, so that they start to spread apart. When they spread apart, it moves them from a solid into a liquid, so therefore melting, because energy is going in, is endothermic. Then if I continue to keep giving them heat and energy, the particles still continue to move faster, where as they are moving faster, then they comes to a point in which the energy changes from making the particles move faster, and then it goes into breaking the bonds and the attractions between the particles to spread them apart to make them go into the next phase, which in this case, going from a liquid to a gas, would be vaporization or evaporation or boiling, where again, it's endothermic because I'm adding energy in. So now when I take energy out, what I'm doing is I'm slowing down the particles. So therefore particles get closer together, and then the attraction becomes stronger because I'm removing the energy now from it moving, so that again, if I'm going from a gas to a liquid, that's condensation. So I moved the screen. As soon as it goes to the next phase, then the energy again starts to change and the speed changes to where it goes to the next phase. So here it's listed that these three phases, which the ones are on that are on top, these ones are endothermic, whereas these three phases, energy is being removed, so therefore these are exothermic. Okay, so now when we're talking about phase changes, phase changes are reversible physical changes, because again, remember, it does not change the it does not change the identity of the matter. But the energy that is being absorbed or released during the phase change, that has to do with the temperature. Okay, so this is all information that you can get from your notes that we're talking about. When we have a phase change, temperature, something happens to the temperature. So remember, temperature is the speed of the particles. Okay, when you have a phase change, that temperature doesn't change because now the energy that is going into the phase change is actually going into breaking the bonds. So we're going to look at a phase change diagram. Okay, so now this is talking about intermolecular forces, which I will talk about. Again, you can get these from your fill-in notes. So here, this is your phase change diagram. So this is showing you on the very top, it's showing you the visual of how water, the particles of water, change from a solid into a liquid into a gas. Okay, so I'm going to explain this phase change diagram. So this is a temperature versus energy being added phase change diagram. So right here, as I have a slope line, so this means, as you can see here, going from -40 to 0, that my temperature is increasing. That's what this means, okay, as I have a slope line. So as I add energy, my temperature increases, okay? So as I told you, as temperature increases, the energy goes into making these particles move faster. As soon as I get to a temperature, in this case 0 degrees Celsius, at this temperature, you should see over the time as I add energy that the temperature does not change, because again, it does not go into making the particles move faster, which is what temperature represents. What's happening is now the energy is going into the breaking of the attraction between these atoms that make my solid into a liquid. So therefore, during this phase change, both the solid and liquid are both present. As soon as the temperature starts to rise again, what that means is now it's going into speeding up the particles, which means I am now at the next phase. I am no longer in a phase change. So again, as this temperature increases, this is just telling me that the energy now is going in to the speed of the particles. Okay, so as I continue to add energy, then when I see that my temperature, so in this case for water, at 100 degrees Celsius, that now my energy is no longer going into the speed of the particles, but now it is going into breaking apart the attractions between the water molecules to make them go faster and to spread them out more. So therefore, now as my temperature is not changing, but I'm adding energy, the energy is going into breaking the attractions. So therefore, I have both phases, the gas and the liquid, during the phase change. As soon as I see the temperature start to rise again, in this case here, as I add energy, okay, that means that now I am in the next phase, because now this is just the gas and the particles again are moving faster, which is what the temperature represents. So this is what a phase change diagram looks for in water. So now your next quiz after your physical and chemical change quiz will be on being able to read a phase change diagram and knowing when we have phase changes and what's occurring to the energy. So you are responsible for this information. We will be completing a couple labs in order for us to see this actual transformation. If you have any questions, please make sure you reach out.